welcome once again. LearnRite, like I used to say, or I've always been saying, we are established just because of you. We are established to ensure that your dreams come through. We are established to walk you through whatever you want to do, particularly by going to the university to do the kind of course that you want and come out to be what you want to be. Our focus is on the sciences for now, but in future, we may add the humanities. For today, I'm one of the teachers for chemistry, and so we are going to still talk about chemistry. Now, last video, we talked about bonding. We look at how naturally various substances that God created exist and operate as they should just because of what you call the attraction or bonding between various substances on Earth. We introduced what bonding is, and we discussed the fact that there are two major types of bonding. The intermolecular bonds and intramolecular bonds, or what we call interatomic, the bond that exists between an atom and another atom within a molecule. So we call that interatomic bonds or intramolecular bonds. And if you take 1 mole of any molecule or 1 mole of any substance, how it is bonded to another mole, and therefore you get that substance existing in a very large form. The bond that exists between a mole and another mole of the same substance is called what we call the intermolecular bonds. Today, we are going to start looking at the types of interatomic bonds that we have. That is intramolecular. Within a molecule, what bonds hold the atoms or ions together to make that molecule. So that's going to be our focus. And if you haven't forgotten, we told you that intramolecular bonds or interatomic bonds, we have 3 main types: the ionic bond, the metallic bond, and then the covalent bond. So we are going to start with the ionic type of bonds. So we say bonding, if I may summarize, we have 2 main types. Interatomic, which is the same as intramolecular. Then we have intermolecular bonds. Under this, we have ionic bonds, we have metallic bonds, and then we have covalent bonds. Of course, when we come to treat covalent bonds, you see that we have different types of covalent bonds. We talk about them. And then intermolecular, again, some of the intermolecular bonds are ionic, or what we call electrostatic, we have some being covalent to, and then we have some being van der Waals forces. So we have hydrogen bonds before van der Waals forces. We have hydrogen bonds, and then we have van der Waals forces. We are going to look at all these types of bonds. So we start with interatomic. If you don't have interatomic, you cannot have intermolecular, because you must have atoms or ions coming together to form 1 mole of a substance before the different moles or molecules can also bond with each other to form that large substance or compound or whatever. And so there cannot exist intermolecular forces if there is no interatomic forces or interatomic bonds. So we first look at the types of interatomic bonds we have: ionic, metallic, covalent. And then we come and take these ones and also look at them. But while discussing these types of interatomic bonds, we'll be discussing intermolecular forces as well. In other words, our focus on each of these, if I pick ionic bonding, I'll be interested in 5 things. I'll be interested in nature and formation. What is the true nature of the bond? How is it formed? That's what I mean by nature and formation of that interatomic bonds. I'll be interested in, if I take 1 mole of that substance and another mole, as long as they are not separated and they drop at 1 by 1, it tells me that there's some force holding them together. So what is the force holding this 1 mole and to this 1 mole? That is the intermolecular forces. I'm interested in knowing for each of these interatomic bonds what type of intermolecular force holds the units together. So intermolecular forces, we'll look at that. We'll be interested in seeing how the atoms or the units of that molecule exist in their crystal form, something we call lattice site. I will explain that when I get there. I'll also be interested for examples of compounds that exhibit that type of interatomic bonding. Examples of that type of bond. In what compounds can we have them? And then lastly, we are interested in the physical properties of such compounds. So we are going to have our discussion based on these interest areas: the nature and formation of the bond, the intermolecular forces that hold the unit of molecules of that substance together, what units occur at the lattice site. I'll explain what lattice site is, and then examples of compounds that exhibit that type of bonding, and then we'll look at the physical properties of molecules or compounds of that type of bonding. So that is a summary of chemical bonding, and that is what we are going to look at. So first, let's start with interatomic bonds. The first type of bond, ionic, or we call it electrovalent, or further still, some call it electrostatic. Get it straight, don't be confused. Ionic, electrovalent, or electrostatic bonds refer to the same type of bond. Now, just look at the name, ionic. It simply means that we are going to talk about bonding that will occur between ions. Remember, in our previous video, we explained what ions are. Ions are atoms or molecules or substances that would have lost or gained electrons. If you lose electrons, you become positively charged, and therefore we say you are a cation. If you gain electrons, you become negatively charged, therefore we say you are anion. Now, once they have these charges together, once they have these opposite charges, they can be attracted by some form of bond which is called electrostatic. Why electro? Electro because of the charges. So let's see how it is formed. So if I say we are interested in the nature and formation, so the first one, we are talking about ionic bonding. The first thing that I'm interested in, as I listed over there, is A. I'm interested in the nature of the bond. Before I come to the formation, what is the nature of an ionic bond? Ionic bond is defined or is said to be an electrostatic force of attraction between a positively charged ion and a negatively charged ion, between a positively charged ion and a negatively charged ion. Once this is positively charged, this is negatively charged, they will always attract each other and they will form a strong force between them like that. That you not see any difference. And so that becomes the force of attraction that pulls them together. That if you don't apply a certain force, they'll never part with each other. That strong bond is called an ionic or electrostatic or electrovalent bond. So in defining it, we say it is the electrostatic force of attraction between a positively charged ion and a negatively charged ion. Comes something like this. It's a force of attraction. What type of force? It's coming from some kind of electricity, electrostatic, because of the oppositely charged ions. So if you are asked to define an ionic bond, you say it is an electrostatic force of attraction between a positively charged ion and a negatively charged ion. Force of attraction. You have explained what bonding is. When we talk about the forces that exist within the atmosphere. In our previous video, we said all those type of attraction in chemistry is called what? Bonding. So an electrostatic force of attraction, once it's an attraction, it is called a bond between the two oppositely charged ions. So that is the nature or the definition of an ionic bond. Now the next one is, remember I wrote nature and formation. If I put it together, nature and formation. So I've explained the nature. The nature is simply an electrostatic force of attraction. Between what? Between two oppositely charged ions. Or we say positively charged ion and a negatively charged ion. How is it formed? I'm coming to the formation. Now, every atom in nature, when we're discussing electronic configuration, we told you, every atom in nature we want to have a stable configuration. A stable configuration. And you know, a stable configuration we discussed in our previous video that it is one that has either a duplet nature or when you have the atom's electrons having what? Being 8. Okay, octet nature. A duplet nature or an octet nature, where the s orbital is fully filled, that is duplet, and then you can have the p orbitals also fully filled, and then have an octet nature. So atoms as they exist will always strive to get to that state. So ionic bond is such that when you have an element sitting and it has some valence electrons, say 1 or 2, and then there's another atom sitting somewhere which has 7 electrons in its atom shell. So if I could get 1 electron, I'll become 8 and I'll be fully filled and I'm very happy. Another atom will also say that, oh, I have this only 1 electron in my atom shell, just hovering around. It doesn't make me stable. Why don't I give it out? So that atom can easily give that 1 electron out, and that atom that needs 1 to fill its octet can also easily accept that 1 electron. And the one that gives out that its electron, as long as it loses that 1 electron, becomes positively charged. The other atom that accepts the electron becomes negatively charged. And once that happens, the oppositely charged ions will automatically come together or attract each other by that electrostatic force of attraction and form the bond. Let me go to a periodic table and start illustrating this. Now, what do we say about group 1 elements? We said they are so-called, that is, they are called group 1 elements because they all have 1 electron in the atom shell. And then again, if we come here, we said ionization energy increases from left to right. So it means that all those atoms on the left-hand side, that is group 1, group 2, they have very low ionization energies. What does that mean? Low ionization energy means that it can easily lose the atom's electron. You don't need much energy to go and take that atom's electron from it. Remember, we said ionization energy is energy required to take an electron. Okay? Why do you need energy? There's some form of attraction between the protons in the nucleus and the electrons out there. So you need energy to go and break that attraction between the protons and the protons in the nucleus and the atom's electron. That is why you need energy. But as you start from the left, the energy required is so low. So ionization energy of the elements on the left-hand side, group 1, group 2, group 3 elements are low, while those on the right-hand side are very, very what? High. So they don't lose electrons easily. If you remember the other characteristics that we learned in chemistry, we said that going to the right, electronegativity or electron affinity is also very high. What is electron affinity? The liking for an electrons, your zeal to have more electrons, it increases. So if electron affinity is increasing to the right, then all those elements on the right hand side, group 7, group 6 there, they have higher liking for electrons because they need electrons to just fill the octet. So whilst the elements on the left hand side here have low ionization energy, which means that you can easily take the electrons, the atoms on the right and far right here for group 7, group 8, remember group O have fully filled orbitals or shells, so they don't need electrons to do anything. That is why when we're describing it, we said they were inert. They don't actually take part in reactions because they are already fully filled, so they don't need electrons. So from 7, group 7 coming down here, group 7 has the highest electron affinity or electronegativity. Group 6 follows with in terms of electron affinity. So if this one can easily lose its electrons and that one easily likes the electrons, they always come together and say that, okay, I'll give my electrons. As soon as I give group 1 element, as soon as I give out that one electron, I become either octet or duplet, and I become very happy. I assume a stable inert gas configuration, and that group 7 element will also accept the electron. Group 7 will accept the electron and also will assume an octet state. That will also be very, very happy. In doing this, it's not just the satisfaction of octet states, but this one would have become positive, and that would have become what? Negative. So automatically, they are attracted by that electrostatic force because of the oppositely charged ions. And that attraction forms that bond we call ionic bond. Let me start illustrating them with key atoms. Let's take lithium and fluorine. Lithium fluoride, okay? What is it? Lithium, we know, has 3 electrons. So electronic configuration 1s2, 2s1. That's one electron in the atom shell. It says, oh, this is the inner shell. So it's got its 2 electrons there and 1 electron is sitting out there. So when it loses this one, it assumes the duplet state and becomes plus. So it loses the electron and it becomes only the inner one with the 2 electrons. That is the nucleus. But it will become what? Plus. Fluorine has 9 electrons. 1s2, 2s2, 2p5. The p5, remember, it can be the 2px2, 2py2, and 2pz1. It needs 1 more electron. When it gains the 1 more electron, the 2p orbital becomes fully filled. And so it will also be happy. So fluorine will have this structure. 2 electrons there. 1, 2, 3, 4, 5. Well, I'm using 1, 2, 3, 4, 5, 6, 7. No. So 8. 1, 2, 3, 4, 5, 6, 7. Yes. 4 is second shell. So what will it do? If lithium has lost that electron will come here. And when it comes here, this one loses the electron to become that. It is now duplet. In other words, in terms of orbital configuration, to become 1s2, fully filled, very happy. This one will also gain that electron and then to become 8 in the atom shell. So here would have become p6. When it becomes p6, then it becomes very, very satisfied. The duplet for the second shell is satisfied. So when it happens, when this one comes here and gains the electron, it happens, this one becomes negatively charged. So this and that will attract each other by what we call the electrostatic force bond. So when you see lithium fluoride written as a compound, the bond that holds the lithium and the fluorine together is that electrostatic force of attraction, where this positive and the negative are attracted to each other. Okay? The same thing happens with, let's say, lithium and hydrogen, or sodium and hydrogen. Why do we say that? If we take lithium, hydrogen, for instance, lithium with the 3 will have the 1s2, 2s1. So when it loses this electron, it becomes 1s2. Hydrogen is 1. Hydrogen has atomic number 1, 1s1. What does it do? What does it need? It needs one more electron to fill its duplet. So lithium will lose its 1 electron to this. So when this one happens that way, then hydrogen, bear in mind, hydrogen is always seen as positive, but sometimes it can be negative. When it meets the group 1, group 2 elements, hydrogen will rather gain the electron. So this one gains the electron, and then hydrogen will now become 1s2. Duplet is filled, and lithium will also become 1s2. Duplet is filled. So lithium hydride, or for that matter, sodium hydride, is also the same. There's an ionic bond, electrostatic force of attraction between the two types of bonds. So that is the nature of ionic bonds. So if you are asked, define, we have defined it already, but if you are asked, what is the nature of the bond, you say it involves an electron transfer from an atom of low ionization energy to another atom of high electron affinity or high electronegativity. The first atom gains a positive charge by losing that electron. The second atom gains a negative charge by gaining the electron. And the two are attracted by a strong force called electrostatic force of attraction. That is formation, which is different from nature. Okay? In the questions, sometimes you ask, define or what is the nature of an ionic bond? And then sometimes we are asked, explain the formation of an ionic bond. The answers are different. Define or what is the nature, you just state it is an electrostatic force of attraction between the positive charge ion and the negative charge ion. What is the formation? Say it involves the loss of an electron, or into brackets S electrons, from an atom of low ionization energy to another atom of high electron affinity or high electronegativity. The first atom becomes positively charged by losing the electrons. The second atom becomes negatively charged by gaining an electron. The two oppositely charged ions are then attracted to each other by electrostatic force of attraction. And that is the formation of an ionic bond. I have explained the formation with 2 examples or 3 examples. Lithium fluoride. We have also seen lithium hydride or sodium. We can use sodium to the same way. Sodium chloride. If I give you sodium, you know that sodium is 11. 1s2, 2s2, 2p, 11. So 2p6, 3s1. That's 1 electron. So you can easily lose that electron and become a 2. Once it becomes 2 here, it means that it is in the inner shell. So the whole first shell is gone. And then if I take chlorine, chlorine is 17. 1s2, 2s2, 2p6, 3s2, 3p5. So this will have a third shell. So this will lose the electron to that. So when it loses the 3s electron, it will have an inner shell, octet filled. And then this one will also gain the electron and become 6. Again, octet filled. They will be happy. But this one become negatively charged, and that will become positively charged. The two attract each other by the electrostatic force of attraction. In diagrammatic form, you have sodium having a third shell. Chlorine also have a third shell. So 2, 8, 8, and then to have 1 here, that is sodium, 11. Chlorine will have 17. 2 electrons there, 8 here, 8, and then here it will have 7. 1, 2, 3, 4, 5, 6, 7. It is one more in the outer shell. So as soon as this one loses the electron to this here, this will become 8 in the outer shell. Sodium will lose the whole outer shell, but it will have the duplet and be happy. And so the two will then come together. So now if we are drawing this structure, it will have just the inner one and then this, okay, forming a bond with, to then come and form a bond with the bigger chlorine atom. So that this will be the negative, this will be the positive. This will have its 2 electrons, this will have its 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And then this will also have 8 electrons in the outermost shell. 1, 2, 3, 4, 5, 6, 7, 8. But the inner shells will still be filled. 8 here. 1, 2, 3, 4, 5, 6, 7, 8. And this will also have 2. So that is how the bonding is formed. Sodium plus chlorine minus. Okay? So that is how electrostatic forces or electrovalent or ionic bonds are formed. I'll end here and I urge you to come with me in the next video where I will explain further and give you some more examples. Thank you so much.